Okay, so now we're trying to do 3, let's see, it's 3 plus 8n. Plus 2 times the prime. Well, this side was, when we looked mod 8, this was always 3. When we looked mod 8 on this side, this was always 1.
Yeah.
That means this.
So, my first question to you is, can P ever be 2?
Well, no, because then you get a 4 mod 8. So 2p would be a 4 mod 8, and that's never going to equal your 3.
Okay, so your initial thing that you said, that the prime always had to be odd and we could never use 2, so you suspected that. Actually, it turns out we can prove that just by looking mod 8. Now I want to see, is there anything else special about the primes? Can you tell me a prime that we will never see in this equation? Besides 2.
Well, it looks like we won't ever see 3. Because twice 3 is 6, and then 6 plus 1 is 7, and that's not 3 mod 8.
Okay, so we'll also never see 3. What about 5? Can you tell me if we'll ever see 5?
You will see 5 because you have 2 times 5 would be 10. That's 2 mod 8.
Okay, so it doesn't tell us for sure that we'll see 5, but we definitely might.
Yeah.
We can't rule it out. We might see 5, and I think we did see
Yeah,
5
I think we
Yeah.
in one of our things. In fact, for 11, right? So 11 was equal to 1 squared plus 2 times 5. Okay, so we did see 5. Can you tell me another prime we can rule out?
I think 7 we can rule out.
All right, let's see.
7 gets you 14, and plus 1 is 15, and then mod 8, that's 7.
Aha. So we'll also never see 7.
11,
Yeah,
so we can also rule
11.
out.
Okay, we can also rule out 11.
I think we saw 13,
We saw
so
13.
that'd be
All right, we did see 13.
26,
Maybe I'll write over
27.
here the ones we did see, 5 and 13. Hopefully that's all.
We saw 17 too.
We did see 17. Okay, so can you see anything that's the same? Let's ignore 2 because 2 is kind of its own special prime. So we're ruling out 3, 7, 11, but we're seeing, we may have even seen 5, 13, and 17. So there's something about these primes, and there's something about these primes. They're the same. But it's a little tricky to see, but you might want to make these lists a little bit longer, or pick a prime and try to figure out which list it goes into, the ones we don't see or the ones we might see.
Cool.
Let's see, it's like, I guess they could be going up by 4 every time. I mean, 3 to 7 to 11. 5 would go to 9, but 9's not prime.
Okay.
So 13, that's 17.
So it might have to do with the mods, mod 8 again.
Okay.
So like, these ones look like they're always going to be 3 or 7 mod 8.
Uh-huh.
And these ones look like they're going to be 5 or 13 mod 8. Well, that's also 5. 5 or 1. 17 is 1 mod 8.
Okay, so interesting. So these primes seem to be 5 or 1 mod 8.
Yeah. And then those ones are, the other ones are 3 and 7.
3
If
and
we had,
7
like-
mod 8. And why doesn't 3 or 7 mod 8 work?
Because if you,
Because you're adding you're doubling it and adding it to 1, and then it never leaves you with a 3 left over.
Okay, and why do these work?
This will always leave you with a 3 left over.
Okay. So now, here's my challenge to you. Is there any way to simplify? So first of all, why does a prime other than 2 have to be 1, 3, 5, or 7 mod 8?
Because that's just odd numbers. Odd numbers have to be odd mod 8.
Okay, good. Is there a way we could simplify the description just a little bit to say 3 and 7 mod 8 or 1 and 5 mod 8? Can we simplify that a little
We're
more?
going to mod 4 if you wanted.
Okay.
So this is 1 mod 4 and 3 mod 4.
All right, does that constitute the full collection of odd primes?
Yep.
yeah.
Okay, so our potential primes are
Only 1 mod 4.
1 mod 4. And the primes we'll never see are
3 mod 4.
So pretty cool. So right away, so this thing that seemed kind of intractable in the beginning, just by looking at it for a little bit, we found that the squares have to be odd, and the primes always have to be, if they show up, the primes always have to be
1 mod 4.
1 mod 4. So we eliminated 2, and we eliminated essentially half of the prime numbers. Right? I don't know for sure if the number of primes that are 1 mod 4 and the number of primes that are 3 mod 4 are the exact same number.
I mean, they're both infinite, maybe.
Yeah, well, my guess is they're probably the same. So now what I want to do is we'll write a little computer program that explores this more than, and we'll see if we can explore it maybe for all n up to 1,000 or something like that.
Okay.
And just see if it's true up to n equals 1,000.
Right.
All right, sound good?
Yeah.
All right, let's do that.